Good afternoon, all the distinguished participants, respected faculty members, and invited guests. I am Dr. Ayani Nandi. On behalf of Ramgarh Engineering College, truly delighted to welcome you all to day 6, that is our final day of our FDP on alternative fuels and hydrogen energy, clean energy innovations for a sustainable society. After an enriching and insightful fifth day, we are excited to continue our journey of learning, exploration, and knowledge sharing. Today's session promised to bring even deeper perspectives, practical understanding, and expert driven discussions that will further strengthen our grip on the emerging trends and innovations in this domain. Your activity of participation, curiosity, and engagement have made day 5 truly successful, and we look forward to the same enthusiasm throughout today's schedule as well. Let us begin day 6, that our final day of FDP, with a new energy, open minds, and a shared commitment to advancing our academic and professional excellence. Wishing everyone a productive and inspiring day 6 of the FDP. On behalf of Ramgarh Engineering College, I, Dr. Ayani Nandi, take great pride in extending a warm and heartfelt welcome to our respective guest, Mr. Vinod M. Wankar Sir, Scientific Officer, Rural Craft and Engineering Division, Mahatma Gandhi Institute for Rural Industrialization. Mr. Wankar sir has been deeply involved in promoting sustainable technologies, rural innovations, and energy efficient practices. His efforts at Mahatma Gandhi Institute for Rural Industrialization have significantly contributed to advancing rural industrialization through cleaner, energy conscious approaches that support both the environment and community well being. Mr. Wankar sir is an accomplished professional with over 18 years of rich experience with both industry and academia, including 11 years in industrial practice and 7 years in academic roles. He holds a master degree in heat power engineering from Savitribai Phule Pune University in the year 2012 and a bachelor's degree in mechanical engineering from Nagpur University in the year 2005. His impressive career reflects a deep commitment to research, innovation, and sustainable technology development. Over the years, Mr. Wankerson has handled 22 projects, delivered 6 professional training programs, and has served as a resource person in several STTPs and FDPs. He also holds 2 patents, demonstrating his strong inclination towards applied research and inventive engineering. Some of his notable projects includes the design and development of a solar-operated vesicant bed dryer, a novel intraoral photoacoustic imaging device for early diagnosis for dental cares, the design of a split-type cooking system for community kitchens, and CFD-based analysis and redesign of animal cages for laboratory trials. His technical expertise span across computational fluid dynamics, that is CFD, thermal and structural analysis, MATLAB, LS-DYNA, Unigraphics, and CATIA. He is also a proud member of the Indian Society of Heating, Refrigeration, and Air Conditioner Engineers ISHRAE. His areas of interest include CFD, MEMS, bioengineering, thermodynamics, and the design of special purpose and agro machine, all of which strongly align with the goals of the FDP on promoting energy efficiency and sustainable industrial development. Sir, we are truly honored to have you among us today. Your expertise in energy efficiency and conservation technologies, particularly in the context of the sustainable development and rural engineering, will undoubtedly enrich our understanding and inspire us to integrate these values into our own academic and professional practices. We eagerly look forward to hearing your valuable insights and experience, which will surely motivate all the participants to adopt innovative strategies for building a more energy efficient and sustainable future. Once again, I extend a warm welcome to you, sir, and to all the participants, dignitaries, and faculty members joining us for this important academic program. May I now request you, sir, to kindly share your thoughts and inspire us with your words.
Thank you, Mom, for your warm welcoming. Uh, is it visible, the screen?
Yes, sir. Yes, sir. It's visible.
Yeah, good afternoon, everyone. Myself, Vinod Vankar. I'm working as a senior scientific officer at Rural Craft and Engineering Division in Mahatma Gandhi Institute for Rural Industrialization, Varda. We have National Institute under Ministry of Micro, Small and Medium Enterprise, Government of Bharat. So today I'll deliver my lecture on the energy efficiency and the building conservations in India. So before I start, I'll just share one thing. Maybe my video is not visible to all as I'm middle of some other workshop. So I'll just stop sharing my video. But my screen is shared with all members. To begin the lecture or thought, I'm just start with the one thought shared by the Rashtrapita Mahatma Gandhi. The earth provide everything to satisfy every man's needs, but not a grade. That was on the foundation for, I thought, today the session that as it says that the we have earth which provide us everything that sustain our needs, but not a grid. Along with this, I will share one photograph here. We start our journey with this type of homes or buildings. We say it's constructed by mods, cow waste. We use bamboos, woods for our homes, and it also contains evaporative cooling. As we progresses, our needs or we say grids transform these small homes to the large towers. Now again, we are focusing on the sustainable sources for our buildings or sustainable materials for our building. In India, as our economies continue to grow, as we know, we are the say fourth largest economy as per economy, and we are moving towards the 5 trillions economy. So our energy demand is also rising rapidly. The industry alone account for nearly 40% of our total energy use, whereas we domestic consume around 25% of total need. And this energy, by using energy efficiency devices or practices, we may reduce the energy consumption without reducing comfort or the productivity. And by using this, by as our mission, that is net zero 2070, which is our target. So, by using energy efficiency devices or practices, we may achieve our net zero missions by 2070. Now, why we require energy efficiency, or why energy efficiency matters in India? As we know, our urbanization of our cities, or the crowds are moving from village to cities for jobs and better livelihood. So energy demands in cities or due to urbanizations are very high. That's, uh, According to the American Energy Society, the average annual change in building energy consumption in India is very high as compared to the any other developed country or developing country. So the countries who are the member of Economic Cooperation and Development (OECD) members countries, you find the South Korea very least percentage 1.5. Now, what this percentage indicates, it's a cumulative, means if any building which consumes the, say example, 100 kilowatt of energy in current year, so next year it will consume 140 kilowatts of energy, that is 1.5%. So same thing, if you non-OCDs, that percentage is very high, and among this India is the highest one, 2.7%. So if we consume, so 100 kilowatt, any building which consumes 100 kilowatt of energy, so next year that building may consume 270 kilowatts of energy. So in India, that consumption is very high. As we follow the modern practices, we lack energy efficient practices because of cost and any other factors that we discussed during these sessions. So, this is a major challenge in India to reduce this percentage. Also, the per capita energy consumptions in India is increases rapidly, which is in 2006-7, which is 672 kilowatts hour. Now this one is up to 22-23 data, and this data is as per the CEG audit. So in 22-23, this one will be the 1331 kilowatts hour. So per capita energy consumption is also increases rapidly in India. Now, another reason for use energy efficiency matters of product is rising electricity tariff. So, the tariff you find here, this one is for the Maharashtra state. We know that every state has its own different tariff. So, in Maharashtra, that tariff is 4.2 rupees per kilowatt hours to 5, and this tariff is for only for 0 to 100 kilowatt hours energy consumption. Now I'm staying in Nagpur, so in Nagpur, which is 2 tier city, so initially it's 0 to 100 kilowatts hour, The tariff is around 5.6, and next 101 to 200 kilowatt hours, the tariff is around 11 rupees. So you find the difference. So this is another major concerns. Rising electricity tariffs. That is that's this is another concern to use energy efficient equipments or practices. Now, apart from this urbanization and electricity tariff cost impact, another one is the environmental and climatic impact also. So, by using energy efficient product or practices, we reduce greenhouse gas emissions, which help India to meet its NDC targets. Now, what is NDC targets? So, NDC is nothing but the national determined contributions, which are crucial commitment made by every country under the Paris Agreement to combat climate change. And they outline each country plan to reduce greenhouse gas emission, adapt to climate impact, and etc. So every country has to submit their NDC plan to United Nations Climatic Change Committee, and they are bound to fulfill this target. So India is also submitting the NDC target by 2030. We are targeting to reduce 45% of our emissions. So by using energy efficient devices or practices, we may meet this NDC target. Now, next one is to reduce air pollution. We all saw on a news channel saw someone who is from the Delhi or northern regions. The during these seasons, winter seasons, the AQI is very high in the cities. So by using, and there are many reasons we discuss during these sessions. What are reasons for the air pollution? How we can combat this air pollution using energy efficient devices. So using this energy efficient, we also reduce the air pollution, then conserve our natural resources, as we are the generation which are middle of everything. Means we saw the India's growth, we have poorness, growth, sustainability, power, everything. But if we are not conserve our natural resources, then our next generation may be question ourselves. You are doing nothing for us. So conserve our natural resources is also important. Then to support our renewable energy integrations. So nowadays there are various schemes government launch, like national solar missions is there, renewable energy systems, then the use of white coal along with traditional coals in thermal power plants. So this support to support our these energy missions, the energy efficient or practice is also required. Then last one is to cut our transmission and distribution losses, the TD losses. India has the highest TD losses. Around 70% to 25% is our TD losses. TD means transmission and distribution losses, that the energy, electrical energy that we transmit from one grid to another grid or to the homes or the industry. So that losses is also very high. By using microgrid and other techniques, we just cut down these steady losses. So these are the main concerns. That's why we go for the energy efficiency matters in India. And along with this, to support this energy efficiency matters or production or the schemes. So government of India launched various policies and schemes like ECBC, Ujalas, B levels. Like Ujalas, we all know that it's launched in 2010 by government of India to support the LED bulbs, LED light in place of CFL or the incandescent that old one lights. Then B labels, 5 star, 4 star, 2 star levels, which is mandatory for all the in the electronics or electrical goods manufacturing companies to make audit and apply these labels. Then the ECBC norms, that energy conservation building codes to support the efficiency. Now, these are little bit some summaries of energy used in India buildings. So I'll divide this one in various factors like primary energy, what is primary energy use, then lighting share, application share, energy demands, what time its energy demand is insulation and efficiency and energy efficiency potential. Now, whatever data I plot here, this is or share with you is from the Bureau of Energy Efficiencies data. So, we all know the in commercial buildings or industries or the ITs, HVAC, and the lighting is the main energy consumption. Major share is owned by the HVAC and the lighting, whereas in residential buildings, we use fans, ACs, and other electrical and electronic supplies, and maybe your televisions, refrigerations, refrigerators. So we are in India. We are not that much fond of use heaters and like used by the European countries. So that, but as year progresses or generation progresses, we may use that type of facility also. So that one is also the major share in some coming days. So HVAC share is around 40 to 55% in commercial buildings. As compared to the residential building, it's around 20 to 35%. Whereas in lighting shares is around 20 to 30% in commercial building, which is very high. So it's like graded like 0 to 15%, 15 to 20%, sorry, 15 to 25% and 29% and then 30% and above. So that share is like high, moderate, and low. Then applications load, like other applications load is very low to moderate in case of commercial building, whereas in residential building it's very high. Application like we are use iron, then refrigerators, then some other vacuum cleaner, some other device which is not a daily use, but we are used some frequently. So that is known as application load. Then energy demand is very high in daytime in commercial building, whereas in residential building it's in mostly in evening. Then in India, we are not that much fond of using insulation efficiency part of any efficiency part while constructing a building or residential home. So it is very poor in case of commercial buildings. Rather than residential, it is negligible. So while it is oftenly poor in commercial building, nowadays there are some buildings or government offices, premises, they are now using the modern techniques to construct commercial buildings. So, but that percentage is very less, say 5 to 15%. Now government are promoting this type of schemes to use energy efficient building or sustainable buildings. Now, what is the energy efficiency potential? Uh, in commercial building, it's very high, and also in residential building is also very high. Now, there are various building conservation techniques, so like passive and active strategies. So now we discuss the passive strategies. In old days, we all we observe that we have houses, homes, residential houses, which are very much found with the architecture, then astronomicals, their locations, then the positions of doors, windows. So astrologically, or we construct our homes. So based on that and the materials also. So as I'm working in a rural craft and engineering department, so I'm frequently visit various tribal belt or tribal areas in villages as we are look after the rural industries. So they describe it as the resources which are not last long with us, like coal or the steel, which is very limited resources. We are using it, and maybe by 2050 or 2060, these all the resources will be diminishes with time. So they categorize it as a asur sort of material. Listen, and not one belt. I will discuss with this with many other areas or villages or tribal belts. So they say it is a asur material. Why it is asur? Because these are diminishes. We are not recreate this material again. So that's why it is asur. And the material which are renewable sources, like most of they use bamboos, then wood for manufacture their construct their houses. So they say it's sur material, God gift material. So likewise, and these are now proven scientific. This is also scientific evidence. The sur and asur. This is what traditional or we mythological part, but scientific evidence also proves that when we use the astrological sort or we construct the building as per construct the building using astronomical part, that one is uh, gives us very good cooling, heating, ventilation parts. The energy consumption is also low. So you find your various pictures here. So it shows that part only. Passive design, construction, and energy efficient home designs. So it also say not only the design, the material that we use. Instead of using the red clay bricks or say concrete bricks, we may go for the AAC block, flash bricks, or if you visit the southern part of the India, they use the flare sort of designs for their home. The what is flare designs? They use the terracotta pots for construction of their slabs. They use the whenever the maximum loading conditions for the slab, they use for the maximum load. They that point they use the terracotta pots. for cooling. I'll show you one photograph here. So, yeah, this. So this type of slab they design. It use terracotta pots for cooling, and scientifically it also proves that by using these techniques, we may reduce our HVAC consumption by 20%. Not only one, they use it for the G+2, G+3 construction also. So planning, while construction planning of windows and position of doors, then kitchen ventilation, roof height, exhaust, it will also reduce. These are some. It will also reduce our energy consumption, and these are some of the passive conservation techniques. Now, next is energy conservation building codes. It's an initiative by the government of India, overseen by the Bureau of Energy Efficiency, which comes under the Ministry of Power, to set minimum energy performance standards for commercial buildings. Now, there are some key objectives are to promote the energy efficiency and reduce energy consumption, and achieve 25 to 50% of energy saving in compliant buildings. Now, it will divide what is applicable. So, it divided in two parts: the commercial buildings and the contract demand. So, commercial building with the connecting load is more than equal to 100 kilowatts, or in contract demand, it's like 120 kVA. Now, this ECDC is launched in 2007, and then again it is as time passes, it is updated in 2017, and it is enforced or handled by individual state government. So they set some standards. So minimum compliance is like 25% of saving. Then ECVC plus plan is like intermediate level up to 25 to 35% of saving. Then super ECVC is like higher standards, like more than 50% of saving. Now, this code covers the area like building envelope, what is HVAC systems and their control, lighting systems, electrical systems, and renewable energy. So what this code say while designing or construction of wall, roof, and windows, the material that the companies or the while construction they use that fulfills the BE norms, and possesses good thermal properties, like it consumes less solar energy or store less solar energy during daytime or reflect maximum radiations. Then 3-star, 4-star, 5-star HVAC systems with smart controls, uh, lighting system, power limits and control for both interior and exterior lighting use most of in daytime use solar sunlight or light during daytimes. The use of I4 or I5 motor, transformer, power factors requirements, and then renewable energy is mandatory. Now, renewable energy means it's either solar energy, wind energy, or any form of renewable energies. Now, using this EC, DC is to transforming broader energy conservation and sustainable building code under Energy Conservation Amendment Act 2022 to include net zero emission goal and separate residential code is also formed like Econova Nivas Samita. It also now formed by the ECBC. Up to now, the ECBC code is only applicable for the high-rise towers or commercial buildings. But now, this code is also applicable for Econima Samhita. The costing of using ECBC code is little bit on higher side, which is if we observe the construction cost, it's 40 to 50% higher than the conventional construction cost. But payback period is also less, means within 4 to 5 years, that cost will be a payback. So after that, we can use on a free of cost type of system that we have, and it's long last also. Now, also there are some other strategies for the building energy efficient, like monitoring energy consumption. Uh, what a strategy I will say here, the total nine strategy. The in Indian context, we oftenly not use this one, but if you start using these strategies, the sorry, we start using this strategy, definitely our energy consumption will be reduced. So first one is monitor energy consumption. So we know that every building, so high rise, whenever it is either it is commercial or residential one. So that building has separate meters, the common energy meters also. So in a month or in 2 months or 3 months, if we monitor our energy consumption, compare with YOY or year on year basis, then we definitely make certain changes to reduce our energy consumption. Then second one is the schedule energy audit. Energy audit is mandatory for the commercial buildings or the industries. But in ECBC norms, the any residentials also they also conduct their energy audit. Now, why is energy audit is important? During this energy audit, also they found that where they're lagging, or where energy consumption is large, or what time that energy consumption is large, and what are the different remedies to reduce the energy. That's why this schedule
হ্যাঁ
energy.
দাও, ডাল ভাত খাওয়া।
Hello.
ওই ডাল খাওয়াও, রোগা হয়ে যাচ্ছে,
হ্যাঁ রে, তো বিয়েটা শখ করে আমার ডায়েটটা হচ্ছে।
মাইনাস হয়ে যাবে।
Hello. Is there any issue?
No, sir.
Ami?
Rajesh Guria, sir, please mute yourself. Wankar,
Okay.
sir, you can continue.
Yeah, thank you. So,
ছিল না হাড়গুলো হয়তো শক্ত
that's
হয়ে
why
যাবে।
schedule energy audit is required for residential as well as commercial building. Then energy efficient equipment. Nowadays, everyone is very serious and aware of energy efficient products. The general public also they are using energy efficient product, even though their cost is very high, but they are asking for the say 3 star, 4 star, 5 star electronics or electrical equipment. So this is good thing for India. Then improve building insulation. In second slide, I will share one data which shows that we are very poor in applying insulations, or we are not used these practices, but in European countries or other countries, they are using these insulation types. So not that for homes only insulation, but we have used minor techniques to improve our building life and also the reduction in our energy and solar radiation. So the small technique is instead of using paint which lasts for only 5 to 6 years, instead of that, if we use tiles outside, if you use tiles to cover our buildings, so the two things will happen. So one is to increase the building lives and the cost of repainting the building is also reduces. And second one is energy. The it reduces the solar radiations and improve the energy efficiency of particular building. Then high efficient light fixture. Nowadays, everyone is use LED lights and fixture even in industry also. In some industry, they use a solar fiber optics also for daytimes. So this one is okay. Then repair any leaks or draft. So oftenly cracks, and this due to that crack, a lot of energy will be lost. So repairing these cracks frequently and draft. Nowadays, AI-based solutions comes. So we use that solution. Also, many government buildings or commercial buildings, they are start using this smart solution when there is no public, that AI or the sensor detect it, then automatically HVACs and then the lights will be off. So these are the smart solution. Renewable use of renewable energy, solar based. Most of nowadays, most of buildings use solar energy or solar panels, and they are separate solar grids also used to produce renewable energy. Not only solar, the wind energy also we are using. So this happens because of government promoting lot of schemes, subsidies to the high-rise buildings, even in residentials. So that's why renewable energy is very use of renewable energy is increased nowadays. Last say 5 to 6 years. So and then second one is the proper ventilation is important. The as I told you earlier, the during the architecture, framing or designing of any building house, if you locate or set proper windows, doors, exhaust, we design accordingly. So this one is also reduces our energy. So now, this strategy is applicable for the new constructions. So apart from this, there is a retrofitting also. Nowadays, lot of house owners, buildings, they do the retrofitting. They are using solar rooftop, solar panels. Then the smart. This one is the old one. So this one you find this one is the old buildings. Now by retrofitting we can convert this type. Sorry, roof insulation. Roof insulation may use a damp proof paint which is available or tiles to reduce the solar radiation. Then improve the ventilation. We modify our windows. The like normal windows to double glazed windows. Then smart metering or AI-based systems we may install, and this definitely improves our energy efficiency. Now, before we continue, I will share you one video, which is Kartavya Bhavan in New Delhi. So then we proceed. Is this video is visible to all?
No, sir, not visible.
Not visible. Okay, let me share. Now it's visible.
Yes,
Yes,
sir.
sir.
Visible.
Yes, sir.
Now, in this video, Kartavya Bhavan, which is a ministerial building. It possesses, say, right now it's open for the six ministry. It's include MSME, DUPG, then SNT divisions, then rural developments ministry and other ministries of Ministry of Heavy. Earlier, these all ministries are in Udyog Bhavan, New Delhi. So these are new construction. They have construct three new buildings, and it's a energy sustainable building. So it contains AI-based smart grid systems. Even the lifts are also AI-based. So in one floor, there are four lifts, and if you any lift, if you press button, it will applicable to the all four lifts. And that AI system then calculated how many people's waiting there in a lobby. So according to the only a single lift will come to that floor, and then it will lift the people. So also the energy, the lighting system is also the AI based. They use most of in daytime they are use most of solar lighting. So during it will luminance of the calculate the surrounding luminous or light, and according to it on and off the lighting lights of that particular room, then HVAC system is also the AI based. So this is very good initiative, but the government likewise there are other commercial buildings also. It uses the solar panels uh, for energy production of its own energy. So it will reduce around 30 to 40% of energy consumptions. Now we move on to the industries. Next part, we know that the major energy consuming industries in India is like cement industry, steel industry, textile, chemicals, paper, which use a lot of energy. Not only the energy means not only the electricity, but it also uses a lot of water for its productions. So these are major energy consuming industries in India, and the major challenge is to replace the old equipment and low efficiency equipment with the modern equipment, because the replacement of this equipment, cost of replacing this equipment cost is very high. So these are the major challenges. As far as the government sector, these are very easy. But when the private players comes in picture, or the private players who are old industries, so replacing this old equipment is a very high or tedious job because of its cost. Now, likewise, we know that the thermal power plants or the any other power plants, the regular thermal power plant efficiency, which is coals or other, so its efficiency is around 29 to 32 maximum efficiency. Remaining are the waste. So to increase the efficiency, nowadays various waste heat recovery systems are used, or use of exhaust gases to again reheat or preheating. Then the high efficiency motors like i3 or i4, which are very high efficient. Then the decomposition of the collected waste or reuse of that waste into the system, automation and process optimization, and efficient boiler and steam system. As I told you earlier, the to replace the old boilers and steam system is costing is very high. Still, there are companies they are replacing the efficient replace the old boilers or old system into the new one, because the payback period is less as compared to the when we use the old boilers or old systems. We are moving on to the next very important scheme that government of India launched in 2012, which is known as the PATS, which is known as the PAT scheme, which is launched by the government of India, Ministry of Power, and it is monitored by the Bureau of Energy Efficiency. The scheme is launched in 2012, and it has given some target to some designated consumers, some industry saving targets, and by saving above that target, if any industry save the energy above that target, then they can on ES certificate, ES means energy saving certificate, and they can then trade these energy saving certificates. So I just told you some of the points that PAT mechanism is why this PAT mechanism is used. PAT is mechanism is used for improving in energy efficiency of energy intensive industries. Like specific high energy intensive industries are identified initially, and they are called as the designated consumer disease. Then the key task in this PAT mechanism is to set the methodology for deciding specific energy consumption norms for each designated consumer in baseline years, target years, then device verification process. Likewise, so the duration of each cycle is of 3 years. Means first cycle is started in the 2012 and it's end in 2015. So trading of ES certificate within the designated consumer disease were unable to meet their target reduction after every 3 years. So CC is calculated like whatever the net energy input into the designated consumers divided by total quantity of output they are exported. According to that, that value is calculated. Now, like I told you, this PAT cycle one is started in 2012 and ended at March 2015. During this cycle one, the government of we was selected 8 sectors which involves aluminium, steel, iron industries, paper, agriculture industries, likewise. So initially they are selected 8 sectors and the designated consumers they are identified as the 478. So during this cycle one, the total energy that saved is around 8.67 metric tons of oil of equivalent, and which transform into the 31 million tons energy CO2 emissions. Now, one ESC certificate is equivalent to 1 million metric tons of energy equivalents. So that is also one point. The company who wants this ES certificate, they can trade it into the non-performing PAT industries. So that next time they also want the same certificate. So likewise, the cycle one, cycle two, cycle three, up to cycle three, the evaluation of ES certificates are completed in cycle one and cycle two. Trading is also completed. But now, from cycle 4 to 6, it's under evaluations. In cycle 4, the B is identify around 8 sectors again. And the certification is under scrutiny in cycle 4. Also, same is for cycle 5 and cycle 6. Now we are on cycle 7, which was started in 2022 and ended in 2025 March. So during these 9 sectors that are identified like aluminium, cement, iron, steel, paper pulp, textile, thermal power plant, railways, and now in cycle 7, the B is introduced DISCOM, which is a distribution company in India. In earlier slides, I told you that India has 17 to 25% TD losses. So this cycle 7, we also introduced the DISCOM, which is distribution companies. Moving to the green building part. So start with what is green building. So green building is a practice of designing, construction, operating buildings efficient and environment responsible waste throughout their entire life cycle. Green building doesn't means to install the solar energy or to install the wind or use of renewable energy only. It Green energy means to use the maximum natural lights, conserve the natural resources, use of water harvesting techniques, uh, the design efficiency resources, use of resource efficiently, then the use of energy efficient material while constructing, reduction of greenhouse gases, and by using all these techniques, the comfort of any human beings or the animal which is also to maintain. So this all together to form the green building. I'll give one small example when we likewise any residential homes or nowadays they are using the solar energy or solar panels for the under national solar mission. So means three to why most of people are using this. So main reason is the subsidies. When we go for the if we install 3 kilowatt to 10 kilowatt of solar panels or solar power plant on our rooftop, so government gives around 70 in Maharashtra. Government gives around 78,000 of subsidies. So that's why most of the people's houses they are installing the solar rooftops. But while after installing solar rooftop also the energy consumption is also increasing. Initially, before installing the solar rooftop, they hardly use ACs or the water heaters, electric water heaters, hardly using. They are using solar water heater. But what happened now after installing this solar rooftops? If they use one or two ACs, then electrical heaters also they are used. So due to this, the energy consumption is also increases. This is not a practice for the green building. When we say that we are follow the practice of green building, that means apart from installing this renewable energy, we also reduce our energy consumptions. So this is the main concept of the green building. Now, why it is so important? While construction of any house or building, say 2,000 square feet home, we typically we produce 4,000 kgs of waste during the land filling or the construction materials, everything, and these are very high as compared to the waste produced by the normal home. And second one is the building consumes more than twice as much energy as all cars. The not only the energy consumption or the indirect pollutions also. Then it accounts 68% of total electricity consumptions of all residential. Then we use we means buildings use around 80% of total drinking water consumptions. Now, 80% of total drinking water, that unnecessary water consumption also it includes. Like we instead of the we use the showers for bath, so unnecessary water then during showering or other household applications also we use a lot of waters. And this increases the indoor pollution 2 to 5 times than the outdoor pollution also. Now, construction waste, as I told you, it 10 to 30% of municipal waste streams. To reduce this, generally nowadays, any architecture or civil engineering, most of them follow the 5R practices for eco-friendly fashion. What is 5R? So reinvent, repurpose, recycle, repair, reduce. These are 5 R's while construction of these are 5 R's while constructing any building. If you follow these 5 R's, definitely our we produce energy efficient buildings, or it also helps our environment to protect. So these 5 R's include reduce, reuse, recycle, repurpose, and reinvent. So what it means? It means a building design based on standard size and the material. Instead of using customized size, if you go for the standard size materials, so wastage of these materials are also reduces. This will form mostly in the bricks. The laborers or the contractor, they generally cut out that bricks, and the most of bricks are wastage. So there is also wastage of material and cost also. So buying high quality to reduce higher quality of material to reduce reject recycle use of scrap materials. The if we dig any sites, we use that same material, digging material, for dumping and for to form foundations. Renovate an existing building. This is more, instead of demolishing that building, if you're supposed to renovate the same building, then that one is the great things. And also the training. In this construction business, most of the cabin or the laborers are the untrained or unskilled. If you train or the use a trained labor or skilled labor, so by using that trained labor also, we reduce the cost and in cost of the building. Another like materials, instead of the traditional materials, go for the engineer or recycle or reclaim materials. Energy efficient placement doors and windows. We can use many a material like bamboo is one of them. Then nowadays the risers for using various husk or biodegradable materials also used to manufacture doors and windows. Glass energy efficient windows are available nowadays, which can cool the buildings during the summer and maintain the indoor temperature, comfort temperature during the winter also. Floor, for the floor covering recycle or the local material is used. Reflective light material is used for the roof material. As I show you one image, in South India they are use the pottery or terracotta pots for cooling. The same thing we use. If we are not going to use the same thing, we go for the damp proof to reduce our energy consumptions. Diaphragm for the slab, and definitely energy efficient appliances is also used. Now, what are the benefits of these green buildings? So, while we categorize these benefits in 3 parts, like social benefits also, environmental benefits also, and economical benefits. So, like social benefit, it improves our quality of life, health comfort also by using the modern appliances or the practices. So that if you go for the recyclable material or the energy efficient construction sites, so it will definitely increase our health and comfort. Then quality wise also it's good. It also reduces the strain on the local infrastructure. It helps to protect our biodiversity, improves air and water qualities, reduces waste and conserve and reserve resources. Yeah, definitely while using or while construction for construction of green building cost is very high, but its payback period is very less, and it will help to optimize the life cycle economic performance, improve occupant productivity also. Now, this occupant productivity is if we construct any commercial building which is energy efficient, your work efficiency is also increased or productivity is increased. That are real seen during visit to the Kartavya Bhavan of the ministry building. Now, earlier it was crowded and very fatigue things happen while visiting this ministry. But nowadays it's very good. The environment is also good, and there is no fatigue while working with in the that new building. So this one is improve the occupants' productivity. Now, then produce we have one case study, which is India's first on-site zero net energy building, and it is the Indira Paryavaran Bhavan, situated at New Delhi. Now, this project is Ministry of Environment and Forest for construction of new office building and New Delhi. Its basic design concept of project is to make a net zero energy green building. So, which construction is started in around 2011 and its construction is completed in 2013. So this one is tagged India's first net zero building. This means that this is a building with zero net energy consumption, where the total amount of energy used in the premises on an annual basis is more or less equal to the amount of renewable energy created on the site. Now, this is one of the reasons why this building is called net zero building. Another one, it use the water harvesting and the ventilations and lighting system also. So it will sustainable building as a renewable sustainable buildings. Now, major achievement includes 40% saving in energy, zero electricity billing, 55% of saving in water. Then that time it's largest rooftop solar power system in any multi-story building in India, which is around 930 kilowatt. This building is rated as a 5-star by GRIA, Green Rating of Integrated Habitats Assistant by MNRE, Leadership in Energy and Environment Design, India, and Platinum by Indian Green Building Council rating. Now, while building planning, they are irrigation. This is all during their design also. Use native species for shrub trees having low water demand in landscaping, low lawn area so as to reduce the water demand. Use of treated water for irrigation, reduce water. Use in building, 55% reduction in overall use of water. This is why they achieve this by using low discharge fixture, dual flushing site wastewater treatment, reuse of treated water for irrigation and cooling towers, for HVAC, use of harvesting efficient water use during construction, and use of curing compound. They follow all the norms of ECBC norms while constructing the building. This is some of the glimpses design you find. There is a stone available in nearby areas for flooring. Terrazzo flooring with locally available stone material, jute bamboo composite for door frame, shutters, UPVC windows, then high reflective terrace tiles. They are avoid aluminium. Then they use old Indian technique, that is sandstone jalis for the air circulation, which kept the building temperature 5 to 10 degrees lower than the atmospheric temperature. They use flash, lime, gypsum bricks. Then the abrasive bricks blocks are used in construction, high efficiency glasses. Now, these are some of the schemes government launched to improve the energy efficiencies in as far as buildings or the residential purpose, like Ujala scheme, which is launched by the Government of India in 2010. It is also known as formally it is known as the Jawaharlal Nehru Ujala scheme or the light promotion schemes, where the most of the buildings and the commercial as well as the residential, the government of India promotes the LED bulbs also. I also share one thing in our organization, MD, we have one division which is known as the Rural Energy and Infrastructure Division. So we give training on manufacturing of LED bulbs. I would like, means happy to share that there are women from the Maharashtra, Leh Ladakh, Northeastern region. They produce their own business on the LED bulb. Not only this, we also provide training to the central jail prisoners. And with Maharashtra, government of Maharashtra initiative now, most of the central jails or jails in Maharashtra, they are using the LED bulb manufactured by the prisoners from the jails of Wardha. Then BE star labeling programs. We know it's mandatory for the all electrical electronic equipment companies to audit their equipment and rate by the or put the rating by BE. Then there are smart cities missions. Government launch smart cities missions to reduce the waste, then increase the renewable energies missions in smart cities. The government of India from September 15th to October under the smart city missions, government of India launched one Swachh Bharat Abhiyan also. From it's starting from 15th September to 31st of October. And major parties start on the 2nd of October, birth anniversary of Rashtrapita Mahatma Gandhi. So under these Swachh Bharat missions, there every year there are some taglines. Now this year the tagline was e-waste management. So under this also there are very lot of initiatives are taken by government of India. Now, there is another national solar mission. So, national solar officially the Jawaharlal Nehru National Solar Mission is a key initiative of government of India launched in 2010 to promote the solar energy, establish India as a global leader in a sector, contribute to the climatic change mitigation. And then the green building initiative is taken care by the government of India to promote the green building. Now, what is future of energy sustainable buildings in India? So we definitely by 2070 or 2050 the net zero energy buildings. Most of the buildings are net zero energy buildings. Then AI driven energy management we use my one of colleague gave a presentation on the renewable microgrids on, I think, on 6th, second day of this FDP workshop, Dr. Sandeep Joshi. So renewable microgrids is one of the future in India, in the green hydrogen in India, in vehicles. This is another future in India. Now we comes to the last, which is conclusion. So during these all sessions, we conclude its energy efficiency is not only the key for India, but it also required for India's future and our future generations. Building either it is residential buildings or the commercial buildings, and the industry have a huge potential in India to save the energy. Now, how to achieve this? We may achieve is by technology, policies by government, and also from our some Vedic system, and which gives us the sustainable growth. Thank you all.
Thank you, sir. Anyone have any questions from participants? Anyone have any question? You may ask now. So from participants, anyone have any questions? We now invite all participants to share their questions. If you have any queries, doubt, or point of any clarification related to today's session, please feel free to ask. Basically, we encourage everyone to participate actively and make this interaction fruitful. Your questions will help enhance understanding and enrich the overall learning experience. So, kindly, please, anyone have any questions? Okay. Thank you so much, sir, for such a motivating and insightful speech. Your speech and ideas have truly inspired us and reminded us of the power of determination and innovation. Your words have given us new insights and motivation to think differently and act with the purpose. The experience and ideas you shared will surely leave a lasting impression on all of us. On behalf of everyone present here, I, Dr. Ayani Nandi, express our heartfelt gratitude for taking the time to be with us today, sir, and for enlightening us with your valuable thoughts. We are deeply grateful for your presence and for sharing your valuable time and wisdom with us today. Thank you once again, sir.
Thank you.
Now, participants, just wait for 2 minutes for next session. Now I am informing few instruction for Atal FDP participants. All participants need to follow the guideline to be eligible for the successful completion of the Atal FDP. That is, participant must maintain at least 80% attendance throughout the FDP. Attendance will be recorded for every session. Failure to meet the minimum requirement will result in ineligibility for certification. And a final assessment test will be conducted today. Participant must score a minimum of 70% marks in the test. The test will evaluate understanding of the key topic covered during this session. Again, good afternoon, everyone. Now, on behalf of Ramgarh Engineering College, I, Dr. Ayani Nandi, welcome and invite Dr. D.K. Singh Sir to address the gathering. Professor Dr. D.K. Singh Sir is a prominent figure in academia, currently serving as the Vice Chancellor of Jharkhand University of Technology. His career includes a significant tenure as the director of BIT Sindri, where he is attributed with leading to become the second best engineering college in India according to 2022 AICTE survey. His expertise also extends to material science and engineering, with previous roles including head of the hematology and at the Wawa Atomic Research Center and a visiting faculty position at IIT ISM Dhanbad. Under his leadership, BIT Sindhi was ranked the second best engineering college in India in a 2022 AICTE survey and ranked first in the East Zone in the same year. He led BIT Sindhi to win the 2022 IFAT India Trade Fair University Challenge and become the champions of the Eastern India Geomining Technocut Fest MINRS in 2023. He has been involved in discussion and collaboration with institutions like NIELIT to enhance educational opportunities for students through internship and faculty development programs, according to this source. He has shared insights on the national educational policy in the year 2020, discussing its significance and implications for the Indian education system. His work and discussion have covered a wide range of topics, including emerging renewable energy technologies, solar, wind, and beyond, critical minerals processing, advanced manufacturing technologies, and the impact of Industry 4.0. Dr. D.K. Singh Sir is a distinguished academician and a respected leader whose dedication to education, research, and institutional development has inspired many in the academic community. His valuable contributions and visionary insights have always guided faculty members and students alike towards innovation and excellence. We are truly honored to have you, sir, with us today, and we eagerly look forward to hearing your thoughts, experience, and words of wisdom. Now I am hand over this session to our beloved principal, madam, to welcome Dr. D.K. Singh, sir.
Good afternoon to everyone. I, Dr. Sharvani Rai, Principal Ramgarh Engineering College, is paying my heartiest welcome first to Dr. D.K. Singh, sir, the Vice Chancellor of Jharkhand Technical University, and also the Chief Patron of this FDP, Climate and Energy Innovations for the Sustainable Society. Thank you, sir, for sharing few of your valuable time with us to make this program successful and glorious by making our faculty members as a participants by and making them benefited with delivering your few valuable knowledge. I am also paying my heartiest welcome to all our eminent speakers and participants as faculty members who are present today. Thank you.
Thank you. Thank you, Saravani ji and your team. And very good afternoon to all the delegates, the resource person, the principal, and all the organizing committee members. It's really a pleasure to me to join today to address this online FDP program. I request the organizer please share my slides. I have sent my presentation slides to your end. Shravani ji,
Yes, sir. We are sharing, sir.
yeah. So my yeah. Yes. Climate change, innovation for the sustainable society. This is a faculty development program. Please go to the next slides. It's a really a theme where I think worldwide the discussions are going there. This is all a responsibility of a faculty member like us and all the innovators, researchers around the world to safeguard the earth. We here in India, we call the Mother Earth, and it is all a responsibility, especially the person who are working in the area of the technology, the teachers, researchers, the scientists, how to protect our Mother Earth and to make our society a sustainable society. So understanding the climate change, the human influence on the atmosphere and the ecosystem, the greenhouse gas emission driving the temperature rise, impact on water, land, and biodiversity. So because of the change in the climate, we all are getting affected. So the theme is how to innovate. So this year, if you go through the Nobel Prize declaration in the chemistry, it was being awarded for MOF, metal oxide framework. So metal oxide framework is an innovation where you go through the research paper and where you go through the researcher detail that somebody imagine in the laboratory that the metals and the oxides can be integrated, can be joined. And when it was joined, it gave birth to a porous material, porous compound, which can capture the carbon dioxide. So God has not gambled with the nature. So it is all the responsibility of the university and the academic institutions to promote the research so that make the air clean, make the water clean, make the energy clean, right? Make the atmosphere clean so that it will be a sustainable society. Next. Next slide, please. Yeah. So global climate trends you go through the last decade was the warmest on the record, increasing intensity of heat waves, storm, global commitments, Paris Agreement, Sustainable Development Goal. You go through these. This is the entire world. This climate suggests that the entire world is dependent, is a common, right? We all are Earth citizen. Because of the political region, we talk about the different country. This is India, Pakistan, America. But in any part of the world, if there is a change in the environment, if we are not going through with the environment, the other part of the world gets affected. So even in the global commitment, Paris Agreement, the Sustainable Development Goals, clean the water, the sustainable, clean the energy. These all are the aims of the Sustainable Development Goals. So question is, this faculty development program, I think during this 1 week program, many researchers, many the faculty have thrown the lights how to protect the earth, how to promote the innovation. Means, suppose my background is electronics, you know, the God has given us the solar energy to the entire world, right? There is no partiality. But as a researcher, we have not put a these days, these decades, you can call it last 2 decades, we are doing a lot of research work in the solar energy. We are improving the efficiency of the photon electron conversion. But earlier, we have been dependent fully on the non-renewable energy, right? If you go through the report of the Club of the Rome, that the oil producing country has done a lobby and they have discouraged the research in the area of the solar energy. But the problem with the solar energy is that how to get the energy throughout the day, how to have a storage energy, how to store it for a longer period. These all are the issue. The startup should take those issues and the challenges. People are now working in the area of the DC grid, right? Because most of the appliances you go through in your home, mostly it is dependent upon the DC. So why not shifting from AC to DC is another issue, right? So I will be throwing some of the challenges. Next slide, please. So impact on the India, unpredictable monsoon affecting agriculture, glaciers melt in Himalaya, increasing the flood risk, urban heat island and air pollution challenges. We all are witnessing this. The monsoon is shifting, right? Earlier up to the 15th September, the rain was supposed to be stopped, but we all have witnessed a rise in the temperature. So this is the right time. In our curriculum, this climate and this type of the issues, we must take it into account. It should be a common paper. It must be integrated in our curriculum, and the faculty member must encourage research and the startup and entrepreneurship in these areas. Next slide, please. So clean energy innovation, solar photovoltaic efficiency improvement, green hydrogen production pathway, battery storage and grid. These 3 areas I'm just throwing before the students and the faculty member. A lot of research is required, a lot of business opportunity is there, a lot of innovation is there, a lot of money is a country can earn. Concentrated solar PV. Now people are working on the concentrated solar photovoltaic cells. Now it is taking less area. It can provide you energy to a longer period of time. Even the Google is planning to have put the solar PV in the space, right, for their data center requirement. Because the computing devices, every day it is increasing. Every bit of the computing devices, every bit requires energy. The second source of energy is the green hydrogen production. The God has provided enough to every country. Our job is, once Einstein said, there is nothing like impossible, right? There is nothing like impossible. It is our limitation that we have not worked enough to extract the thing. God has given everything, we have to explore it. Battery storage and the grid modernization. Battery storage, a lot of materials research is working there, right? New materials are coming. Now the stone which we were calling it is of no use. Now people are searching a new material for the battery storage, right? China and the other country, even the Afghanistan and other country, where people were saying that there is no natural resources, but people are now working. There is a resources where through which those resources can be utilized for the battery storage. And the grid is the older one. We have to shift to the DC grids because the conversion from AC to DC and DC to AC, a lot of energy loss is there. So a lot of startup and innovations is required in this battery storage, green hydrogen production, solar PV. Country has also started, country like India has also started a solar mission program, a green hydrogen mission program. I request all the researcher, all the faculty member, right, you go through the non-conventional energy department, MNRE, Ministry of Non-Renewable Energy. These all missions are there where you can apply for some projects, for some startup grants, and you can do it. Because any country economy is being decided by the investment in the new technology, the innovation, because export and import, that decides the country economy. When your export is higher than the import, so naturally you will be a powerful country financially. So we have to do a research, we have to promote research in the area of the clean energy innovation, and these research start from the academic institution. So let the Jharkhand University of Technology is reorienting their curriculum and are including this clean energy in the part of a curriculum, so that every student must be exposed, they must be encouraged to work in the area of solar PV, green hydrogen, and the battery storage. Next slide, please. Next. So where is the problem? There is also a problem with country like us in our public policy. So our policy of the infrastructure, all the big apartment and the other government building, there must be a secured guidelines, right? The regulatory body must force that the building must be green, it must have an energy audit, low carbon cements. Now people are working using a cement using low carbon and steel technology, smart mobility and urban planning. In the smart country, smart city you go through, even in the Gulf country, most of the developed country there is a smart city. Not everybody is using the car, but there is a public transport system, but it is so smart. So through those practices, people are reducing the carbon level. Next slide, please. Next slide, please. So we are lucky enough that we are living in an era of the digital technology, and we all have witnessed the impact of this digital technology. Now the AI is not for the future, rather AI is the present technology. So AI for the climate modeling and the prediction, right? So earlier the data capturing and the data analysis, somewhere the tool was not so powerful, but because of this artificial intelligence, we can do a modeling of the climate and we can predict about the climate, we can forecast about the climate. IoT for the smart water energy management. You go through the country like Israel, other country, they are using the IoT for management of the waters, right? They have put there the sensor, and through that water management can be done. GIS and remote sensing for the environmental monitoring. So these AI, IoT and GIS, the new models, new versions. So all the researchers have the opportunity to work in this area, use this technology for innovation, for a startup, in the for the sustainable development and for the environment. Next, please. So circular economy is nothing reuse, recycling of the waste. Our country, a population, highly populous country, the waste management is the greatest challenge. So the circular economy, so reduce, reuse, and recycle. So we have to convert the waste into energy, waste into the wealth, waste to the energy technology, industrial symbiosis and resource optimization. So these are the issues where a startup has a greater opportunity. They have the greater financial opportunity. Waste, I think if anybody has planned to work in the area of converting waste into the energy, they have a great future, because a lot of technology is required, a lot of challenges is required, and the market is visible. You don't have to search the market. The government is the biggest market. The municipal corporation is the biggest market. So try to promote your research in those areas where easily the waste can be managed, waste can be converted into the energy. So this is a opportunity for the circular economy, means the recycling can be done, the waste can be done, the wastewater can be recycled to a clean water, the energy can be again can be utilized. This is an area, so a lot of opportunity is there for the startup in the circular economy. Next. So what is our role? Our role is that the climate curriculum, our role as a vice chancellor, as a principal, as a faculty member, as a HOD, our role is to integrate in our curriculum the climate, impact of the climate, the technology to monitor the climate, the technology for the circular economy, interdisciplinary research initiative. There are different domain of the knowledge which can be integrated for the sustainable development. Collaboration with the government and the industry. It is academia. You take the research project from as we are living here in the Jharkhand. Those waste as can be converted in building the roads, can be converted again into energy. Next. Next slide, please. So we are living in the mines and the minerals environment, balancing the mining with environment conservation. So we are doing open cast mining, and these all are the practices through which we are doing the mining. Really, our environment is getting polluted. So here the startup must come forwards. They must provide a solution to have a less impact on the environment while doing the mining. Forest ecosystem and the tribal knowledge system. The tribal knowledge system here can be utilized to have a good balance between without doing the mining, extracting the minerals without affecting the environment. So potential for renewable and the green energy. So a startup have a great opportunity, a great avenue for working in the area of renewable energy, green energy, right, and the green hydrogen. Next. So capacity building, I think this faculty development program is a capacity building, different part of the country, the faculty members are joining here. So it is an opportunity for you to build a relationship, collaborate with them, share your knowledge, integrate with the industry, integrate with the government schemes, and do a research in collaboration. So promoting a student-led innovation projects, creating a sustainability clubs and the forums, because a student of the 21st century, they want some exciting projects. it is all the responsibility of the academia to provide them. So in the Jharkhand particularly, we are living around a mines and minerals dominated area where a lot of this extraction, this industry are affecting our environment. So same time opportunity is there for the students and the faculty member and the researcher and for entrepreneurs, the startup who wants to do some research work, some innovation in this area. So next slide, please. Next slide, please. So let us start from our own campus. So solar rooftop implementation, we should switch over from our energy utilization with the non-renewable to renewable solar rooftop implementation, green landscaping and biodiversity park, water harvesting, waste segregation, and the energy audit. So it is all our responsibility. We should first utilize in our own campus, then it will be a good model to spread over to the entire society. Next. Incubation support for the green idea. I think there are many agencies, the government schemes are supporting a startup in this green, startup in recycling, clean technology and agriculture, industry partnership for scaling and innovation. The industries are ready enough. Earlier, 10 to 20 years back, industry was not supportive, but right now the government has come forwards. They are pushing the startup culture. So you have a great opportunity to collaborate with the industries because the industry is the biggest market where you can utilize your innovation and a startup for converting your idea into entrepreneurs. Next. So policy support is one of the biggest aspects in managing this climate change and the national mission. So we have in our India a national action plan on the climate change, national green hydrogen mission, India net zero 2070. Just I would like to remind you that Jharkhand University of Technology in collaboration with the MECON, we have also submitted a projects for green hydrogen. I think this project is there in the Ministry of MNRE, and I am hopeful some projects we will get it. So country has already planned a net zero 2070. By 2050 it will be 50%. So let us come forwards, do a research to reduce the carbon, make earth a place where our coming generation will live with satisfaction and peace. Next. So community-centric climate solutions, awareness program for the rural communities. It is all a responsibility of our academic institution. We should create awareness program for the rural communities. So how to use a clean water, right? How to make our energy clean, capacity building for the farmers and youth, utilize optimal utilization. So IoT technology and this latest technology, you can make them aware how to use it, the sensor. Integration of the traditional ecological knowledge system. You go through the area of the Delhi around the Haryana. You might have gone through. जब फसल की कटवा होती है, a lot of carbon dioxides they are emitting. So you have your role, make them aware how to have a balance between the development and this environment, protection of the environment. So community-centric climate solution, the academic institution role is there to make them aware, the farmer and the youth, about how to protect the earth through this deterioration in the climate. Next. So sustainability as a collective responsibility, sustainable make earth a sustainable. So this is all a collective responsibility of the society, the academic institution, all the researcher. Innovation as a core driver for the progress. Any country cannot survive without innovation. I was going through one of the quotes that Americans are billionaire because of their startup and innovation, but India still is billionaire. Some of the billionaires are doing the business, but we have to innovate them. But we are lucky enough that we are witnessing in last 10 years that a lot of startup, a lot of our brilliant minds are now coming in the area of startup. So commitment to the climate resilient, this is our future responsibility. We should work in that areas to protect our earth. Next. So with these words, thank you very much for giving me opportunity. I missed the opportunity to come there at Ramgarh Engineering College, but within I think in the coming months I will take some time to interact with the faculty members there. But this program is in online mode. I hope all those faculty members who have joined this faculty development program on climate energy innovation for sustainable society, they will start promoting the research in those areas. The student will be given some exciting projects. You will be collaborating with the industries. You will be collaborating with the government agency to work in these areas. So with these words, thank you very much. Namaskar, Johar.
Thank you, sir. Sir, I have a request, like kindly on your video just once, sir.
Video is not on. Video is on.
Okay, okay, sir. Okay.
Oh, sorry. Sorry.
Sir,
Sorry.
yes, sir.
Now is it coming? Yeah.
তোমার টক করবে তো
Mhm.
Now video is on. It's okay?
Okay, sir. It's okay, sir.
Yeah. Video is on.
It's okay,
I'm
sir.
here. I'm visible now. Sorry. Phone
No,
was
sir.
video. Yeah. You might have requested earlier. Yeah. Okay,
Okay,
thank
sir.
you very much. Thank you very much.
Thank
And
you.
thanks to the organizing team for conducting such a nice FDP program, faculty development program. I'm sure the next phase of the Atal FDP program, you will start soon. So wish you all the best to the organizing team and all the participants who have joined this program.
থ্যাংক ইউ স্যার বললো
Thank you so much, sir, for such a
may-
motivating and insightful speech, sir.
Yeah, may I take a leave now to join another meeting?
Yes, sir. Yes, sir. Thank you, sir. Thank you so much, sir.
Thank you. Namaskar.
Namaskar, sir. Now we are going for 2 minutes break. So all the participants, now it's break for only 2 minutes. So, good afternoon, everyone. Again, we are back for today's schedule. So, as our VC sir is busy for his schedule, so now I am sharing my thoughts on this topic. So, in this today's topic, emerging renewable energy and technologies, solar, wind, and beyond. So, in this topic, I am sharing my thoughts as I got some time as our VC sir is busy. So, nowadays, the power industry integration of the renewable energy sources and electric vehicle is the fundamental to achieving the sustainable development by reducing the greenhouse gases emission and promoting the resource of the efficiency and creating resilient infrastructure. So renewable energy like a solar and wind provides clean electricity, while EVs offer a way to decarbonize the transportation sector and can act as grid stabilizer by shorting and providing power back to the grid when it's needed and creating an synergic loop for a cleaner energy system. So this synergy is essential for meet the climate goals and for a transition towards the low carbon future. So in this slide, we can see that the renewable energy sources like solar energy and wind energy and the photovoltaic solar farms and rooftop panels for the solar energy. And then we can see the onshore and offshore for the turbines and the large scale grid. And also includes the geothermal, tidal, hydro, and hydrogen. So there are now existing power sector, the thermal power, hydropower, and all are in existing mode. But in when we use the renewable energy sources, then we have to optimize, and we can connect the several types of renewable in a sector, and then we have to optimize. So after that, we can see in the next slide, we will see that how we can optimize those system and how we can relate those system to get the maximum profit in power industries. So basically the power industry is moving away from the fossil fuels to cleaner renewable sources like solar and wind to generate the electricity. This reduces the greenhouse gases that lead to climate change, and when this clean energy is used to charge the electric vehicles, it further reduces emissions and compared to the traditional gasoline powered cars. So when we use the electric vehicle, then there are some parameters. So EVs are not just the consumers of energy, their batteries can be used also to be the stabilize the power grid. So they can store the renewable energy from the periods of the high production, like from example, as an example, we can take the solar power during the day and release it during the periods of the high demand in case of the evening time. So reducing the strain on the grid. So this thing is when the power is from vehicle to grid and grid to vehicle. The two operations are very much important to consider these cases. So this allows the electric vehicles to actively sell the power back to the grid and providing a valuable revenue stream for owners while supporting grid resilience. So the combination of the renewable generation and electric vehicle charging creates the variety of the cycles. So the renewable energy sources like solar panel can be correlated with electric vehicle charging stations, allowing for the self-sufficient charging that doesn't put the additional strain on the grid. So this approach ensures that the transportation sector becomes a part of the solution for decarbonization rather than begin a major sources of the emission. So basically how and every solar panel have its own capacity as per the specification to convert the solar energy to electrical energy. Now, basically the synergy between the renewable energy and EVs is the major driver of innovation. So it basically advancement in the battery technology, smart charging infrastructure, and grid management systems. This also create new industry and jobs contributing to economic growth and sustainable industrializations. And there are the several environmental benefits. Now we are discussing about the environmental benefits of the for using the clean and green energy. In urban areas, a shift to EVs powered by the renewable sources directly improves the air quality by eliminating the tailpipe emission, which leading to better public health outcome also. So electric vehicles are connected to clean and green energy for sustainable development through their ability to significantly reduce greenhouse gas emission, improve air quality, and less dependence on fossil fuels, especially when charged with renewable sources like solar and wind power. So this basically this synergy between the electric vehicle and clean energy contributes to sustainable development by mitigating the climate change, promoting the technological innovation, and creating a more resilient and a healthier transportation system. So the environmental benefits are also include the reduce of the emissions. Like electric vehicle produce zero tailpipe emission, unlike the gasoline and the diesel car, which release the harmful gases when charged with the electricity generated from renewable sources. They achieve a much lower carbon footprint and help combat climate changes. And they also eliminating the tailpipe of the emission leads to cleaner air, and especially in the urban areas, which can reduce the respiratory disease and improve public health also. Basically, the quiet operation of the electric vehicle motors make urban environmental quieter and the more peaceful. So, and also the EVs powered by the renewable energy decrease the reliance on the oil and the coal, which are the finite resources and source of the geopolitical tension. The growth of the electric vehicle market drives innovation in the battery technology, charging infrastructure, and other clean energy solutions, which creating also a new job and economic opportunity. And it is also the affordable and the efficient in the long term that the cost of electricity can be lower than the fossil fuel, and the electric vehicle are often more energy efficient than the traditional vehicle. So here in this picture, in this slide, we can see there is a number of the interconnection of the network, that means grid, and from generation to supply, we have to maintain some parameters. Like EVs can help to stabilize the electrical grid by shorting the excess solar and the wind energy and releasing it when it needed. And solar panel combined with EVs can create decentralized energy system, reducing the strain on the grid and enhancing the energy resilience. Now, in this slide, we can see that here we can see that there are the power quality difference. In this graph, we can see there are the several types of the power quality difference. That normal, then swell, then sag. So next slide, we can see the several type of the power quality difference. So basically, when we generate a power and it goes to the generating station to distributing station, in between there is a main part is transmission. So at this time, we have to maintain the power qualities also. So how we can maintain the power? There are several types of the disturbance. So like flicker, harmonics, overvoltage, unbalance, sag, swells, frequencies, notches, etc. So the main thing is like that we need to gain the profit. So how we can gain the profit? By using those things, by using renewable, and when we consider the vehicle to grid and grid to vehicle operation, including electric vehicle, plug-in electric vehicle or hybrid electric vehicle. So basically, how we can control the, how you can meet the energy demand or load demand of per day, and by maintaining the profit of industries. So how is this possible? So let's go some overview in that topic. Like that, nowadays the size of the power system is increasing day by day due to the heavy load demand. In there are the several types of sector like agricultural, industrial, commercial, residential. So that due to this, the power system is growing. So if the power sector is growing day by day, then it is basically necessary to decide for power generating station like that which generating unit should be kept on for the particular hour, and for what hour it should be kept off to meet the time varying load demand. And after that, we have to maintain the optimal generation cost also. So basically, what is that? That is, every generating station is basically made by the several power generators which are connected in the parallel mode. So after parallel generating connection of the generator, all generator is not in all condition for all time, and all generator is not in off condition for all time. So we need to decide such kind of generator will be in on condition and such kind of generator will be in the off condition to meet the time varying load demand. So how many generator we need to on and how many generator we need to off, how we can decide? Okay, so meet the time varying load demand. So this is our one parameter, one factor. So we need to decide this, and by deciding this, we need to gain the profit of our industry. So how we can do this? Let's see. And another portion is like that. Here in this graph, we can see for in case of the renewable energy sources, there are the several types of the demands. Like in summertime, it will be another, and winter time, it will be another. Okay, so solar uncertainty also we have to taken into the consideration. So by considering this, and we have to consider the another power plant also, then when there will be the peak load demand, when there will be the base load demand, and what will be the power demand in case of the winter and in case of the summer. So we need to maintain those things, and including to generate the power. So renewable energy sources plays the major role in meeting the time varying load demand as well as the environmental protection. Also, it is the very complicated to get the profit-based unit commitment. So what is the profit-based unit commitment problem? Like Unit commitment means if we consider the several generator is per unit generator, then which generator will be considered to in on condition and which generator will be considered to in off condition. So those when those generator is in on condition, then we can say that those generating unit are in committed mode. And when those generator are unit in committed mode, so at that time it will fulfill the power demand within 24 hours and by getting the optimum solution. And what is the optimum solution? Optimum solution means how the power sector or power industry can gain the profit from that. So we need to maintain all those things. So here we can see about the optimal power flow. That means the generator real and reactive power which allowed the vary within certain limits. So that means when power is generated, there are a certain limit. One is minimum limit and another one is the maximum limit. We need to maintain the generation of the power within the minimum limit to the maximum limit. And maintaining also the operational cost. Cost is the main factor for gaining the profit. So when any industry wants to gain some profit, then we have to maintain the cost. So what type of cost we have to maintain? There are the several costs like total fuel cost, operational cost, maintenance cost, and crew cost. So all need to maintain. So all have to maintain as a constant. Now here we can see the main part is that we have to maintain our cost. That means we have to lower our operational cost and we need to high the efficiency and the quality. Our quality as well as the power efficiency also. So how we can do this? Basically, there are the several types of the unit commitment problem, like conventional type unit commitment problem, profit-based unit commitment problem, and security constant unit commitment problem. So both the three types of the unit commitment problem, basically the profit-based unit commitment problem is the basic concern because everyone need the profit. So company also need the profit. So how we can get the profit? So this is the equation. Basically, maximum profit we can gain from revenue minus total operating cost. Okay. So basically, the primary purpose of the unit commitment problem has basically changed in the maximizing the total profit, which lead to the emergence of a new concept which is known as profit-based unit commitment. So here we can see that there are the several type of the cost like fuel cost, staff salary, interest and the depreciation charges and maintenance cost, which are the some components for operating cost. So I am showing you some experimental research on this topic. So how we can maximize the profit? So maximize the profit when we just reduce the total fuel cost. So how we can reduce the total fuel cost and increase the revenue? Okay, so this is the equations of the revenue part. So by using these equations, we can get the revenue part. So what is that? If we consider the H means the total interval of time in hour and NG basically means the number of the generating units. So we can consider delta as an energy price. P is power generation of ith unit at each subinterval in megawatt and U is the each unit. That means the status of ith unit or each unit at each subinterval of the time. That means in which hour which unit in off condition and which unit is in on condition. We can find out by this the status of the unit. And this one is the power generating part, for which hour what generator is generating how much amount of megawatt power we can identify from this. So here in this slide, we can see that the fuel cost. So how we can get the fuel cost? Here see the fuel cost is like, in this equation, we can find out, like there are some cost coefficient. A, B, C, D, and E is known as the cost coefficient of ith generating units, as we consider I as the number of the generating unit. And here we can see that is startup cost. Now, what is that? When some generating unit is in off condition, and then that unit need to in turn on condition. So at this time, the cost which we need, so this is known as the startup cost. So this startup cost is very much important. Now, what is the HSU and what is the CSU? HSU is basically known as the hot startup unit. Okay, that means like when a unit is already in the off condition, and in the off condition of that unit, we need to be in the on condition. Then this cost is known as hot startup cost. And in case of when some unit is in run condition, and then we need to the off condition, then it is cold startup. So when some generator, here we can take an example, practical example of the number of the generating unit commitment. Like here we can see unit 1, when that means this is my generator 1, this is my generator 2, and this is my generator 3. When it is in only have 3 generators, then we can easily calculate like which generating unit should be kept in on condition and which should be kept in on condition for what a particular hour, and how they can meet the time varying load demand. We can easily calculate from using those formulas. But when we have 10 generating units, then how we can calculate? This mathematical manual calculation will be the very complicated. And when will be the 100th number of power generating unit, any power station, then how it will be possible? And up to n number of generators. So, and also we need to maintain some constraints. That means some limitations, like we have to need spinning reserve. Means we need some generator in hand. Like when some generator is in running condition, when the fault occur at that time, then we need to out of that generator from